first one, you would do 18 divided by 35, right?
Yeah, because p hat is, oh, I need my notebook. Yeah, because p hat is 1 divided by the other, right? Or
x divided by n.
Like the one thing my daughter knows how to do in statistics, and so she's like, that has to be an easy class. No, it's not just dividing.
It is not.
Honestly. And I show her it all, and she's like, yeah, that looks easy. I'm like, oh, whatever. Not a chance. Okay, so you said what divided by what?
18 divided by 35 for p hat 1, and then p hat 2 would be the 17 divided by 35. Wait. Yeah, because who can? So it would be the, no, it would be the different. It would be 52 divided by 94, right? For female, for p hat 1. 0.553, because it says the question is the proportion of females who can taste PTC different from the portion of males who can taste. So it would be the yes column, the yes line, so it would be 52 divided by 94, and then 42 divided by 94.
Who can, yeah, who can taste it. You said, so it's, yeah, 52 divided by 94, you said, right? 52 divided by 94, and then 42 divided by 94, right?
Right.
Okay. Sounds good to me. 42 divided by 94. Okay, I need to find my calculator because I moved where I was sitting. Now I have to look for it underneath. There we go. Under the blanket.
Okay, what's the difference here between, are you on 5 yet?
No, hold on. I haven't thrown it into my calculator yet because I was looking for it. Okay, so did you get 0.553?
I did.
And then 0.447?
Yep.
Okay.
All right, so 5, what's the difference? Oh, okay, never mind. I see the difference. So it's either the first or the last one.
It's different, so it's equal to or not equal to.
Right.
Oh, P1 is equal to P2.
And then the last one is p hat.
Oh, these are so confusing. Okay, yeah, it's the first one and the last one.
I would say probably the first one.
And I still get confused on the difference between P hat and P without the hat. You know?
Let me look in the lesson and see.
Okay.
I think it's the first one.
Okay. That's kind of what I was thinking because my paper doesn't have any hats on it when it says
Right.
the data. Wait. Oh, that's just for the requirement check. Requirement check, I'm seeing hats. All right, let's try it. Not, we'll know later. Create a 95% confidence interval for P1 minus P2. Wait. Are we sure it's not P hat? No. P1 minus.
Yeah, I don't think it's p hat.
Okay. Okay, so then now are we using Excel at this point now?
Yeah, I'm gonna plug in these on Excel.
Okay. So we're going with.
Hey guys, sorry, I'm only an hour.
Hey.
What's up?
Sheesh. What number are you guys on?
We are on number 6.
Yes.
Yeah. The point estimate for 50% confidence interval. So P1 minus P2.
Okay, so the first 9 questions are this one.
So how do you know where to input the numbers?
In the Excel sheet?
Yeah, so like there's the X1 and then the N1.
Well, it's
How do you know the order?
sample 1 and then sample 2. So it would be X1, N1, X2, N2. I need to find that sheet. They don't give it to us, huh? Easily.
Which sheet?
Did we do the other ones right?
I don't think we did.
I don't think we did either.
Maybe we should wait. Let's have Megan help us with those other ones because I'm like looking at this and I'm like, wait. How do we know these things? Okay.
Okay, so question 3.
Gosh,
I
dang it.
recall only seeing word problems in both the videos that we watched for the homework and then in the homework. Like I don't recall seeing charts. You know what I mean?
Still trying to find the Excel sheet. What's that one? What is it called?
Categorical data analysis _ hat.
So P1 is the females who can taste. So it's the females, yes. And P2 is males, yes.
All right, I got it.
Okay, so P1 is can. P2 is
So
men.
P1 females yes is 52 divided by
But are you doing divided
70.
by the total sample size or just by the female?
I
Is
would
it-
say 70.
Yeah, like 70.
So,
And
yeah.
then
Is that what you think, Megan, too?
Yeah, it would be 52 and then 70 and then 42 and 59.
59.
Okay.
Yeah. So you put that into your Excel sheet for so
Catch, Elise.
so it would be 52, 70, because remember N is just the sample size. And then 42 and 59. Does it tell us confidence level or are we just assuming it's 95?
I think
It's 95.
55.
And then is this less than,
It's not equal to.
not equal to? Okay. Okay. So let P1 be the proportion of females who can taste. P2.
Oh, no. I didn't realize they give you the p hats in there.
So use the data in the table to find P1.
So that would be the 52 divided by 70.
Mm-hmm. So it doesn't tell you in the chart. You still have to do that part.
Do you see in the middle where it says descriptive statistics? It shows a p hat 1 and a p hat 2. And I just plugged it in the calculator and it was right.
Oh, I see. Oh, okay. So it does tell you.
Awesome.
52 divided by 70 is, oh yeah, the 0.743. Okay. And then the P2 would be the other one, 0.712.
Yeah.
And 5, which set of hypotheses is appropriate?
Don't say anything, Elise. Let's see what Megan
I'm
says.
not.
Well, it's either the first one or the last one.
It's exactly what we said.
Yes.
Hey, but remember, was that with you, Elise, that we learned about the P hat? So when we're doing confidence levels, it's the P hat, but when we're doing hypothesis, it's just P.
Okay, I need to write that down.
That's true.
Let me
No.
write that down.
Wouldn't it just be A then?
That's the one that we put.
Oh, okay.
So you said p hat
Is when you're dealing with confidence interval. But hypothesis is P. Oh, you're a king. Oh, you're a king, baby. Okay. Honey, they're doing their work. Okay, go away.
How cute.
Okay.
Megan, I should tell you, the other day you left and your son was on there and he was like picking his nose or something, and I thought it was you for a second, and I was like, does she know like the camera or what? And then I was like, oh, it's her boy.
Oh, that's so funny.
All you could see was just like, you know, just
Yeah.
from here, and I'm like, oh man.
I don't know
That's
what you
funny.
heard. I'm sorry.
No.
Oh, that's funny.
Quiet. Okay. Okay, point estimate is your z-score, right?
Mm-hmm.
Here's your z-score. 0.394, right?
Mm-hmm.
94.
What is the margin of error?
And the margin of error, I remember this.
Mama. Oh, you're saying mama.
Yay. The upper bound minus the lower bound divided by 2.
Yes. But what is, I'm still confused on the last exam. That is right. That is the formula. But do you remember like on the exam, sometimes you didn't need to do that? I still didn't quite get when you need to do that and when you don't. Does that make any sense? Maybe not. Yeah, I don't know.
I don't know.
I don't know.
Yeah,
I have margin of error is m equals the z-score square root of p, all of that. So you don't do that?
I was just looking for that formula. Where's that at?
I don't know. I wrote it in my notes on lesson 17.
Yeah, no, I see that too as well, but but for the confidence interval, I have the formula as being upper bound minus lower bound divided by 2.
No, but we're not looking for confidence. Oh, we are. Well, no, it's the margin of error for the confidence interval.
Okay, wait, question.
Yeah.
The Z on the Excel sheet, isn't that the test statistic?
Yeah.
So,
Estimate.
because there's a formula for the Z-score. Oh, the point estimate.
The point estimate is the Z-score, right? And so it's already put on there.
But the Z-score on the
Excel
sheet.
Statistic.
Oh, on the Excel. Yeah, you know, I wrote that down. Let me see. I think you're right, Elise. It is.
What is the point estimate?
No, well, the Z, that one may not be correct.
Yeah.
Isn't that what we're saying here?
Yeah, I have Z is the test statistic. I don't know what point estimate is. Oh.
Ugh.
I don't know if I have it written down or not.
Oh, I know I ain't. Okay, are we looking for probability? I gotta go back to my homework. No, we're not. Okay. Well, I have in my notes probabilities about proportions. Is that even what we're doing right now?
Not yet.
Okay, because that's in 16. We're in lesson 18. Maybe I should stick with that. Okay. What is the margin of error for 95% confidence?
Wait, what was it? I thought we were doing point estimate again because we weren't sure.
Wait, point estimate. Oh, on 6?
Yeah.
Mm-hmm.
I will search for it.
Okay, so I'm looking on lesson 18, and I'm doing a search for point estimate.
Yeah.
And it's not popping up.
That means it's probably the one that we learned before, because we're doing 2 proportions, but this should be applicable for the 1 proportion, which would be in 17. So the Z now this is for hypothesis though, because there's a difference between the hypothesis testing and the confidence interval. I don't know. I think the test statistic is the Z in the Excel because notes that I took for types of hypothesis, when he says for 2 proportions, he gives the formula, but he said you can do it by hand, but it's in Excel to compute the test statistic, and it's
Is the point estimate the X bar?
It used to be, yeah.
But
that's what it was in prior lessons. I don't know. Did it change? Mark, can you grab him, please?
I don't know. How do you find the X bar?
That's a very good question. Determine p-value based on test statistic. Use applet. Okay.
It's the sample mean. The sample mean is the point estimate, right?
Okay.
Well, let me look at this question again.
Well, on the information, it says create a 95% confidence interval for P1 minus P2. Input your answers for the point estimate, margin of error, and lower bound and upper. I don't think it changes from what we used to do. So because they want to know point estimate, margin of error, and then the upper and lower bound, which the upper and lower bound is easy. But the point estimate is what we compare against the p-value, right? Or I mean against the margin of error.
Right.
I'm so confused.
So this lesson didn't give us a new formula for the margin of error.
No, that's what I'm saying. I think it's probably the same as in 17.
But wouldn't you have to incorporate because it's more than one proportion?
True.
So would it be like
How do you find the sample mean? How do you find the sample mean? Because isn't that going to be your point estimate?
Yeah. Confidence interval. What is the point estimate? I don't know. I feel like all of this information should be on an Excel sheet. We just don't know how to read it.
I'm just gonna keep it as what it's at.
What's that?
For number 6, I'm just gonna keep it the 0.394 and see if that works.
Okay. That's fine. I mean, if we get it wrong, we can ask her or something.
Because it should be on this Excel sheet somewhere.
Right. It's on the other ones too. So then the margin of error for the 95. Yeah, when it's 2 sample means, I didn't see any examples of that.
I didn't either.
But yeah, you're right. That could you treat it like when it's 1? That doesn't make sense.
Yeah, it doesn't. Yeah, because you add everything and then divide, right?
Yeah.
All the data observe and divide.
It's the one that I have from last lesson.
Oh, is it because we're wait. Is it because we're only looking for, hold on, I have to go back. Is it because we're only looking for the people that said yes? So are we saying it would be, no, I'm sorry. Wait.
I don't know. Because I have for the formula, he said that it's estimating the true difference between the 2 population proportions for the confidence interval.
Did we say 94 divided by 129?
What? Where are you?
For the point estimate, 94 divided by 129?
94 divided by. Oh, let's see, under the total. I don't know, guys. I don't know about this one.
How did we get the number we got, Elise?
Which one?
6?
That was the Z on the Excel sheet.
So what is the margin of error for the 95? Yeah, I just need to go back and how do you do the margin of error normally? I'm all confused now. So I have z-score and then the square root of p, 1 minus p divided by n. What if we just did that, but based on...
But which p would you use?
Right, and then which n's? Do you add them? Yeah, I don't know.
I don't know. I just have like for the confidence interval where it's talking about confidence intervals, I have upper bound minus lower bound and then divided by 2.
Yeah, well, we could do that since we don't know. I mean, something's better than nothing. So
Yeah.
upper bound minus lower bound. So that's 0.185 minus negative 0.123. And then divide by 2 is 0.154.
That's what I got.
Okay, well, we could do that. Just see.
Worth a shot.
Yeah. 154. Lower bound. Negative 0.123. Diggy. A 0.5. What decision do you make?
Wait, what did you get for the margin of error? Did you get negative 0.0?
We did 0.154.
What?
Did you make sure that the lower bound was negative?
Yeah, it's minus negative 0.123.
Oh, negative 0.123 minus 0.185 and then divided by 2. What did you get? Negative 0.154?
Yeah, but it's positive. You did them backwards. You did negative 123 minus 0.185. It should be 0.185 minus negative 0.123.
Oh my goodness. Okay, I'm so glad.
It's the same numbers. It's just positive instead of negative.
I put that in and got something different.
Okay. So
positive 0.5. Right?
Oh my gosh, I'm so hungry.
Can you guys hear me?
Yes. What did?
Oh. Okay.
Sorry, being loudly. What?
Oh, I was just asking about that question again, but.
So it's the 0.185 and then minus and then
negative.
I ended up figuring it out.
3 with negative. Okay.
It just took me a second.
No worries.
Okay. All right, so lower bound. We have negative, hold on. Negative 0.123.
Uh-huh.
And upper bound 0.185.
The p-value is higher, so.
So the first one?
What was the sigma?
The p-value is 0.693. So,
And that's greater than the
yeah,
0.
we're using the point.
What does it
Yep.
give? Oh, I'm so dumb.
So we have insufficient.
High, keep the guy. So fail to reject. Fail to reject. HA.
Mm-hmm. So
the third one down on question 10. Right?
Is it the first one or the third one?
If P is low, HO must go.
Because we're rejecting the null, right?
First one. Right? Because if P is low, HO must go.
if P is low,
Yeah.
but P
So then
is not.
It's high. I'm just saying it's HO, not HA, because you're keeping HO.
Okay,
Sorry,
so if
complicated, but it's
P is high, we keep the guy, right?
right. If
P is high, we keep the guy.
yeah, so it's failed to reject.
Yeah.
I'm saying it's HO, not HA.
Oh, yeah. Failed to reject HO. And
Yeah.
so then it would be that we have
Insufficient.
we have insufficient evidence to support. So yeah, we're rejecting, or we do not reject the null, and then we have insufficient evidence to say, okay, this is not going to work. Hey, Mark.
So is it the last one then?
Oh, that's loud. Okay.
We're doing
I'd say it's the last one.
Last one.
yeah.
It just needs to restate the null or the alternative hypothesis.
Yeah. Something like that. Yes.
Okay. I gotta move him. I can't see him.
All right, guys. I have to run, but I might be able to jump on when I get to work.
Okay.
Because I don't think my student is here in Phoenix today, so I'll have some downtime between schools. So.
Okay.
All right. I might see you soon then.
What'd you say, Elise? You gotta go?
Yeah, but I might be able to jump back on when I get to work, so we'll see.
Okay. Just watch the video if you don't get a chance.
Okay. Sounds good.
Okay.
Bye.
Oh, yeah.
See ya.
Who's recording? Are you, Joe?
I am. Mm-hmm. Yeah. Guess it's a good thing. Let's see. Okay. All right.
9 questions. Hallelujah.
Mortality rates and day of admission. Heart attacks.
Oh, good. This was in the example.
So is our sample size right? Yeah. So we just have to, yeah. Okay.
Mm-hmm. But there's two groups. Okay. So let P1 be the proportion of patients who had a heart attack and were admitted on a weekday who died. And let P2 be the proportion of students or patients who had a heart attack and were admitted on a weekend who died. So the proportion of patients who have a heart attack and are admitted to the hospital on a weekday would die less than the proportion of patients. I think he's not feeling good. He's teething. He probably needs Tylenol.
You didn't finish the cereal.
Oh, okay.
You want to shake in the bottle?
I don't care. So less than. Okay. So I'm going to write out the hypothesis is that P1 is equal to P2, and the null hypothesis is that P1, holy cow, sorry. Can you hold them while you're doing that? Okay. is less than, right? P1 is less than P2 because P1 is weekday.
Uh-huh.
They're saying people die less on a weekday than on the weekend.
Yeah, so P1 is less than P2, right?
Right. Okay.
Yeah.
So
P1 is less than P2. And then conditions are true, right?
what are the conditions for hypothesis? They're that it's random sample. So this would be a random sample because they're not controlling it. And what was the other condition? Are independently obtained using that. Oh, and then that they are greater than or equal to 10.
Yeah, and they are. Wait, no.
Well, we need to do. We have to do the math really quick on it, right?
Yeah. Oh, oops! I put my numbers in wrong. Yeah, you have to put it into the calculator. No, just put it into Excel. It'll tell you.
Oh yeah, duh. All right, I gotta put mine into Excel.
I just put the wrong numbers into Excel.
Oh, okay.
Just make sure you flip your numbers because
I know.
they're backwards. It was out of this many, rather than this many out of this.
So it's 16713 is the first one.
Yeah. Yep.
1, 6.
Yeah, I'm excited to see the results of this one.
118519. Those are big. Okay. And then it's 6155.
Pretty sure their sample size is big enough.
Yeah. 2, 447. Okay. And you got to change it to less than. Okay.
Oh, good point. Change it to less than.
Keep it in at the 95. Confidence
is less than P2.
Okay. So, are they true? Yes, they are very high.
Yes, I think we're good.
And then 13. Which set of hypothesis is appropriate? Oh. See, we already did it.
Yeah.
First one.
First.
Okay. Use the data in the table to find people. Oh, see, they're going to ask us the same questions. And we're not even sure about all the...
Wait, why did you say the first one?
13? Yeah.
On 13, isn't it the last one?
Oh, you're right. I wrote it wrong. Because they're saying that people die more on the weekend.
I think so. Let's reread.
Go back and reread that real quick.
P1 is a portion of who were admitted on a weekday. Is the proportion of patients who had a heart attack and were admitted to the hospital.
They die less than.
They die less than the portion of people that had a
greater than.
Yeah, so.
Good eye. Good eye.
Why, thank you. Use the data in the table to find P hat 1. 0.1141. 141. Use the data to find PP2. 0.145.
It's gonna suck if we get those other ones wrong, so we're gonna have to input all this information again to try to figure out the right answers.
Yes.
Okay.
Okay, for negative 2. Can you have a negative, or does that make it a 0?
No, z-score can be negative.
Okay.
That just means that the confidence interval.
Oh, I'm thinking of.
They're going to be low.
Okay.
Okay.
Yes, I see. I see. Okay.
Given the z-score for the last question, which should you trade? The right or the left or the right of the z-score?
Oh my goodness. I should know this.
It's greater than, or no, less than, so it would be to the left.
Left. Yes. Oh,
Right?
I guess.
Not, but left. Well, think about it. When we go to the applet, if we were to put that negative z-score in, we would shade left and then put the negative in. Right?
I don't know. I just put the negative in. I don't shade. Maybe maybe I've been doing it wrong, and that's why I have a C.
Well, we can even check it because we have the p-value, and if it's green,
Did you just
I'm
say
pretty sure it's left. Yeah,
Okay, then
you
just
have
say
to shade.
the chocolate.
So
Oh, Megan. Okay.
what?
Did you say something about eating a chocolate?
Chocolate?
Okay.
What?
I thought, and then I asked you like 3 times if you had said that, but
Oh, I didn't hear you. I'm sorry.
yeah, because
I'm eating.
like,
I'm
maybe
eating.
that's why I had a C, and you were like, if we get it wrong, maybe we can eat a chocolate, is what I heard. But
Oh.
thanks.
No, sorry. And then I'm chewing loudly, so I can't even. Sorry. I'm
It's
not,
okay. It's okay.
I'm like half here.
No
I'm
problem.
just so hungry. Okay. What is the decision? Well, the p-value is 0.798 against the, wasn't it 0.05?
P-value is 0.022.
Wait, what?
Yeah, it shows it in the little chart next to the Z.
0.978.
What? Change it to less than. P1 is less than P2.
Oh, I didn't do that. Thank you.
No problem. I was like, how are you doing something different? Wait, you better.
Oh, yeah, that would.
Does this
Okay.
stay the same? Negative 2.020 when you did that?
Actually, I can't hear better because these suck.
Turn up.
Where?
No, on the thing.
Oh. Hello?
Yes.
Oh, only one of them worked. It's okay.
Me?
Yeah, but these earphones are not very good.
Okay.
Okay, so it's 0.022. Well, it's still greater than 0.05. And so
What are we?
P is high. We keep the guy.
5.05.
So we fail to reject. Right?
No, P is low.
P is lower.
Then maybe I'm looking at the wrong question, actually.
Well, no. Oh, because it would be 2.2 and this would be 5.0. Is that how you would interpret it?
I'm getting the p-value is 0.022.
Yeah.
Significance level is 0.05. So P is lower than that.
Oh, okay.
Right?
Yes. So you reject the null then?
Yes.
Mm-hmm.
Low HO must go. So reject the null hypothesis.
And then we have sufficient evidence to say
I'm just going to double check this. Yeah.
blah, blah, blah.
There is sufficient evidence to conclude that the proportion of patients who have a heart attack and are admitted to the hospital on Tuesday who died is less than the proportion. Yes. It's the third one down. Let's see. What's the other one?
Yeah.
Oh, yeah.
Who died.
Not equal to. So, yes, it's the third one down, right?
Mm-hmm. Mm-hmm.
Hallelujah. I finally understand that.
That's what I'm thinking.
But let's see what it says when we see
Yeah.
it.
Yeah, it's not. No, it's insufficient, and it's not the first one. So, or no, I mean, we know it's sufficient.
Yes, sufficient.
Okay. And
Yeah.
it's not the same proportion. So, yeah.
Yeah, it's less than.
Okay.
Well,
I'm gonna submit.
that's cool because I don't know. It's finally a study that like is interesting to me.
Yeah.
That people die less
Yeah.
on a weekday. So if you're gonna have a heart attack on a weekday.
That's right. Not the weekend.
But
Apparently
guess
they have
what?
lots of doctors.
This class finally makes sense. Jimmy.
Oh, see, we did get number 6 wrong. The point estimate. We got to figure out what that is.
The point estimate
On number 6.
on number 6.
That's it. All the other ones are right.
There was
Just
something,
kidding.
hold on, there was one thing I was going to try on that one that I was like, oh, maybe it's this. Hold on.
Yeah, try it.
Okay. Hold
We
on.
also got number 18 wrong.
We got
Which,
8.
how do you even get that wrong?
94.
Oh, because I didn't switch it. That's why. My bad.
Okay, hold on. Let me see if this works, and then I'll let you know. So which one you said? Number 18. Oh, you didn't switch yours. Oh.
I didn't switch it, so that's why I got it wrong. So I'm gonna correct that. But yeah,
Okay, hold
what other formula are you gonna do?
on. Hold on, let me look.
Okay.
I'll tell you if it was right. And what did I do? Hold on, I got a couple wrong. How did that happen?
But to go back, I gotta put in that other stuff to figure out the point estimate.
Oh, I missed question 8. How did I do that? I must have not changed it or something. I put something in wrong. The lower down. I should have got that right. What did you get for question 8?
What number?
Question 8?
That's the negative 0.123.
I forgot the negative sign. And then I got question
What
6.
are those negatives? That's so funny.
I got question 6 wrong too. So I'm not even going to tell you what I did because it was wrong.
Number 6? Well, I got it wrong too.
Yeah, I know. And then I changed my method and I got it. So, okay. So I just need to fix that one unless we can figure out how to.
Gotta figure out this point estimate crap.
Yeah.
I know we've done it before. Thanks, baby.
Right. Oh boy. Okay. Well, so I'll just see here.
Having my Diet Coke and Cheez-Its for the day, you know. So
Yeah.
healthy. So healthy. I like that you did it on Google Hangouts. Wait, is that what we normally use? That was different. Oh my gosh. I'm so off. I know when I saw it, I was like, oh, she's doing Google Hangouts. She said she wanted to change it. I'm so dumb. Oh my gosh.
That's so funny. What did I want to change? Now I'm curious what it was that I wanted to
Well, you
change.
said like, oh, well, let's do that. It was a different, you don't remember that?
I
It was
don't.
a different, maybe it was hers, the one that she uses, Zoom.
Oh, gotcha.
Or maybe it was Skype. Maybe that's what it was.
Broadcasting, so you quit.
Yes, I was thinking this was